Okay, so January 24th, been 6-7 months since the last video. That was when we were recording with the drone footage from the solar installation, which has been functioning fine. It's pretty stacked, so it's easy to deal with. I have an app on my phone that I can track all my data for that. No production today because it's the snow panels have been covered in snow. We got about 10 centimeters in the last few hours, so we're getting a ton of snow. So no production right now, but that's when it is. We had no hydro bill all summer long once we got approval from Hydro One to produce 10 kilowatts onto the grid. So essentially those are credits that you get. You got to use them up in the year, otherwise you lose them after the fiscal year ends. We're all designed so that we're always going to be owing them a little money. We don't want to be overproducing. Not until the deal changes. If Ontario changes to be more like California regulations where they pay you for everything you make, then I would probably add more solar because the house is designed for a 20 kilowatt array. The roof space will give me 20 kilowatts under current panel sizes at 350 watts per panel. And, you know, we're seeing higher panels and efficiencies coming too, so we'll see. We'll be able to produce more energy in time. So today's a really good day because it's like minus 16 degrees Celsius today with the wind chill. And the house is heated completely by electricity, right? So no gas in the house. There's no gas, there's no carbon-based fuels that are into this home. It's all being operated through electricity. In Ontario, we are producing no electricity from carbon-based fuels. In our area, it's all coming from the nuclear plant in the Bruce and some from Niagara Falls, which is hydroelectric. Ontario still does have some carbon-based fuels producing energy from some of the gas plants that are running, but no coal. So Ontario's doing a really good job of cleaning up its grid as far as that goes, way ahead. So that said, let's take a look at this heat pump. It's a Mitsubishi heat pump. I will show you in a second what that looks like. And then I'll go down to the basement and show you some of the thermostats, the controls, etc. once now that the house is done and you get a little bit of view of the house. We'll do more of a full-blown talk about how the house is as neutral for carbon in its manufacturing and its build as possible. And a big issue that I've had with some of the net zero homes here in Ontario are their cheater homes in the sense that they use a gas furnace. I have no gas coming in my house. It's all electric. So let's go ahead and take a look at that pump, that heat pump, and give you some details on that. Okay, let's head over to the exterior of the unit. The heat pump is critical for a net zero home. How you heat and cool your house is critical. There are other net zero homes in the area in London, Ontario. One was built by Sifton, and I think the Doug Terry homes in St. Thomas. But they all use a gas furnace to heat and cool the house. So I look at that as a bit of a cheat on the net zero, even though it's allowable by the Canadian Home Building Association standards to hit net zero. But in my mind, no carbon is the best way to go. So no explosives. There are no carbon-based fuels in this house. It's all electricity. So I don't have a gas meter on my house. That's my neighbor's house. Mine is all electricity. So you'll see here, that's the power going in and out of the house. And that's your AC lines going into the house. And DC's inside the walls. So the beauty of a heat pump, so it's sitting, this particular pump is the Mitsubishi with the H2i compressor on the exterior of the house, sitting on a concrete pad on 4 rubber feet. You can see the power coming off of it. It's a 230 volt line that runs into it, and then the power for the blower unit inside the house runs off of that 230 volt line off the back of this particular unit. So that's how that works. This H2i technology is amazing. It needs clearance so that it can do its job. And this particular unit is a Mitsubishi PVA 42AA7. It's a 3.5 ton system with a 48,000 BTU for it. It's got a SEER value of 15.5. And but that's, you know, for heating and cooling. I think that for a better value to be more concerned about when you're choosing a heat pump is the HSPF value, which is the heating seasonal performance factor. And for this particular unit, it's very high at 10. There's some units that are a little higher than that, but at the time this was the best available one that I could get service for. So that's the other thing is not too many people selling in Mitsubishi Electric, and this was all was done by Select Heating and Cooling out of Woodstock. So it was hard to find the right heating and cooling guys that can do that. So you want service, right? The higher value is the better. This particular one is 10 is an HSPF, so that's just the heating. Cooling is less important because cooling is dead easy with the heat pump, right? Heating is a little tougher, especially when you get to those lower temperatures. This is good to down to minus 13 degrees Fahrenheit, which is about minus 25 Fahrenheit, Celsius. I think it'll get to minus 30. We've had some minus 27 nights with the wind chill. And it was heating the house comfortably to 18, 19 degrees at night. So that's the brains of it. That's the brawn of it. This is where all the work is being done inside that cabinet. Because the unit inside the house is really just a blower, and you can see the grill on the other side of it. And this thing goes into a defrost mode when it needs to. And it's all sitting on top of those rubber feet on top of a concrete pad that was pre-poured just for it. Okay, so that's the unit itself. It's the barn and the brains of it. So let's head back into the house. We can take a look at some of the thermostats and controls and the electric motor controls for the thermostats. All right. Let's head in. I think it's been warming up. It was minus 16 earlier. House is all fully alarmed. Security cameras. Fiberglass insulated door. Native hardwood from Tilsonburg. We'll do a separate video completely on the carbon neutrality that we were aiming for the house, and where we couldn't hit carbon neutrality. The rest of it is going to be balanced out by planting, so trees being planted. Each zone of each level, so there's 3 zones, has a thermostat. That's the Honeywell control, so I control all that by my phone. That lower panel was if you wanted to go active control or passive control, where I could run the ERV separately. That cable's able to do that, but we decided to do it all passive, which means that every bathroom has a control and it's done automatically. There are no fans in and out of each room. We're not dumping any energy from the house out. It's all gonna go through an ERV vent, and it's all done passively, so the house's exchange is occurring all the time. Now, air exchange is critical in a house that's so well insulated. So this is Passive House Standard certified, so we hit 0.5 air change units, ACUs, in this house. So it's super insulated and super tight. So air change is all happening through the ERV, and then that really just leaves a concern for humidity, and we'll talk a little bit more about that. In the house, we were aiming for as much carbon neutrality as possible, so that meant local materials, locally made. For example, the couch is wool, made in Ontario. The cabinetry is all made by a local carpenter with materials from Ontario. Kamoka Cabinetry did that, all custom made. The kitchen cabinets are all by Dynamic Kitchens. They were all custom made and they're all locally manufactured. The flooring is all harvested out of sustainably harvested forests for hardwood maple, which are all native species to Ontario. So those are the kinds of choices that were made throughout the build to hit as much carbon neutrality as possible. So we're gonna head down into the basement. Basement is an insulated concrete foundation. The house in general is 60 in the roof, vaulted ceilings, 40 in the walls, and in the basement we're 30 in the wall and 15 in the floor under slab. So we're heading into, and there's a little dehumidifier that I've been using to hit to around 45% humidity. In the new home, there's a lot of humidity from all the new materials. And over the long haul, we'll have to see how that performs. The ERV, which we chose, which is a Venmar AVS, that's the X24 ERV series, the X series. It does all the in and out of the air coming in and out of the house. So we get some dehumidification through it. But when you've got an 80% humidity in the exterior, you're going to get humidity in the interior. So you only want it to get so high So it's something that we didn't consider when we were building. We thought, oh, humidity, dehumidification should be fine through the ERV. But here in southwestern Ontario, we can get some really humid days. So I might just keep the little unit here and run it as needed, just to take take the edge off of some of the humidity. So as I said, the blower unit, because that's all this is just a blower, the Mitsubishi blower unit, for the which is the mated blower unit from the compressor outdoors. Those are the refrigerant lines coming in and out, because that's what heat pumps are all about. Heat pumps are all about compressing heat through refrigerants and passing them back through into the house. That's what it's all about. So compressing even cold air has warm air if you compress it. So that's maybe a counterintuitive thought, but that's exactly what you're doing. So is a three zone system. One, so that's an electrically actuated valve that opens and closes that plenum valve, and there is the sensor for it. There's zone 2 with the valve, the motorized valve, and the sensor. And let's see, the third is up there. So again, the motor and the sensor. So that's the blower, Mitsubishi blower, with a custom built plenum on the top. And then if we move along here, you'll see the refrigerant lines that head to the exterior, to the unit we just saw. All right there, heading outside of the building there through that hole. You have to pardon all the Ethernet cable, but the house is a smart house, so every level has a half a dozen ports for a hardwired Ethernet connection, and that switch operates all of them. And then off of that, every thermostat, 3 floors, 3 zones, and a thermostat for each, and those thermostats are controlled by those 3 little switches. Rogers 1 gigabyte system, Google Mesh, blind control. That's the inverter. It's connected through an Ethernet cable to the router, so I get all my data from an app. 200 amp panel, a true 200 amp panel, so I think it's 220 rated to 200. The system, and then the controls for the master, and the 3 sub panels for each thermostat for the 3 zone system. And then just to boot, we put in a Rheem heat pump with a Wi-Fi connection, so I can control the heat pump from a phone or an app or a computer. Okay, so to finish up, that's the hybrid heat pump water tank, water heater. It is the water for it is preheated by the ambient temperature in the room. That's the Rheem Prestige series, the Proterra. And the upper part of the cabinet is the heat pump portion, and the lower part is a glass-lined tank. It's a 50-gallon US gallon tank. Looked at in a tankless, but the tankless current draw and the energy required, even for instant burst of energy, is still a lot more expensive to operate than a hybrid heat pump like this Rheem. This is one of the best in the market, the Rheem Prestige series. The Proterra is one of the best. It's Wi-Fi enabled, so that I can adjust it and see all its activity through my phone. Part of its EcoNet apps service. All the water is not only preheated from the ambient air in the room, which is usually about 19 degrees Celsius, but it's also plumbed with that little motor there to pull the water that's being pre-treated from this coil. So that is a coil for the wastewater tank on the wastewater line, and essentially that coil is circulating water through it. Through the length of it, it's a 5-foot coil, and that coil is preheating the water that's going into the hot water tank by capturing water from the wastewater line. It's not a ton of energy, but it all counts when it comes to heating water. Water is one of your biggest heat consumptions next to your furnace. So accuracy in what you're heating, so that's through 3 zones, so heat just the area that you need, not the whole house all the time. You heat just the zone according to its temperature and according to what the thermostats are set at for each level and each floor. So heat rises, so we have the upstairs set at a lower temperature, and the basement's so well insulated that with the heat rising, we don't need too much heat down in the basement for us to get what we want to rise throughout the house. So there's some of that passive. The system is fully active. It is not a passive system running through the ERV. I said passive a couple of times. I was thinking passive house standards, but actually it's a fully active system. So there are no fans operating in the bathrooms. The whole house is going to circulate its air every 15 minutes. So it's not necessary to have a fan sucking treated air out of a bathroom and dumping it into the environment because of some smells. The ERV is going to capture that and exchange it with exterior air to the outside, and it's doing that actively all the time. So no switches in the bathrooms for dumping air to the outside. Okay, so that's it. Thanks for enduring the length of time between videos, and the next video will be probably in the next couple of months to talk about carbon neutrality. Thanks.